Okay, this is November 3rd, and we're finishing up our first week on probability. And at the end of this week, we have a demonstration 2, which will cover counting, maps, sets, and a little bit of the tail end of, there's a couple questions on logic, one about the patterns of deduction, and some of the, like, there'll be a table of the conditional proposition for the truth table for that. So just to remind you of that, because that's so important. Okay, so there's where we are. And on Piazza, I put up a new exercise sheet, this probability exercises, and we're going to go over that because that will act as a review of what we did last time. And you don't, this is not to turn in, this is just a class exercise, but you can download it and then maybe during the class, whether you're doing it later or now, you can then sort of fill in the blanks. And I will put my answers up too. And so you'll have my copy of this with answers as well as the blank version here. It's under software resources on Piazza. Okay, so that I think is the what's going on with that stuff. And let me go ahead and we'll start. Well, first, let's see. Well, I guess we can start with the exercise sheet, because that will also act as a review. Now, the first exercise here is actually the one that's in the textbook that we did last time, which is about we had a probability experiment, which is just some controlled experiment or activity which has very precise set of outcomes that you've defined. Like here, you roll a 4-sided dice, and the outcomes are, well, one die, which side face up is going to have a certain number of dots on it, and so we can give a name to each of those as to how many dots are up. So we can label the outcomes with the numbers 1, 2, 3, 4, and then here's a sort of a picture, sort of just a visual picture of these numbers 1, 2, 3, 4 as the different possibilities. And the purpose of the diagram just is sort of like as if, well, if this was a box and you sort of randomly tossed a marker in here and it bounced around, it might sort of, you could imagine it landing eventually in any one of these 4 things equally likely, which is going to be our classical probability model. So you label the outcomes and put the labels in there, and then oh, so I may as well just go ahead and fill this in. So even though this is the same exercise we did last time, but I can just, so you see what the idea is, because we'll do problem 2 is a little different, and I'll have you guys work on that. Okay, so the event 1 is the event in which the outcome is just one die, the single dot showing on the dice. Now the events are subsets, they're sets of outcomes. So here, the sample space is the set of all the outcomes. So an event is any subset of the sample space. So here, what the intent is to write down, well, it's the set that just includes this one outcome. So the idea here is just to get used to the idea that an event is a set, and using set notation, naively, you might not want to distinguish between outcomes and sets, but that's important just for what's going on for the model, because to each event we assign a probability, which is the number of outcomes in the event, the size of the event divided by the size of the sample space. So that's why it's important to have the event as a set. And then for here, this is just going to be 1/4, because so that the probability that event 1 occurs, that the outcome is a 1, is 1/4. And then here is a second event, which is the outcome is 3 or less. Well, if we define that as a subset of the sample space, it's going to be 1, 2, 3, like that. So here's the definition of that event as a subset. And then the probability as a formula is going to be the number of elements in the subset divided by the sample space. Didn't know of a better word than formula for the definition. Maybe putting the word definition here is better. And here you'd have 3, and again 4, because there's 4 outcomes in the sample space. So the probability that the that you see a 1, 2, or a 3, that the event is 3 or less, is 3/4. Now, how about this event, in which any outcome occurs? Well, this is still an event because it's a subset. It's 1, 2, 3, 4. It's actually the sample space because it's all the outcomes. Well, again, the same formula applies, but here, since it's going to be 4/4, which of course is going to equal 1. In any probability model, you have to have the probability of the sample space equaling 1. And this is and the meaning of 1 is always happens. The flip side of this is when you had the probability of the empty set, which for a good probability model must be assigned to 0, and the meaning of this is never happens in the context of the probability experiment. And again, to repeat, it's important to realize that probabilities are fractions, not percentages. So, for example, if the probability was 1/2 for some event, you don't want to say it's 50%. 50% is a statement about statistics, that you roll the dice 100 times and 50% of the results were heads up. So statistics is about sort of what happened in the past. Probability is a prediction of what happens in the future. Just a minor notational thing. Okay, so here is the one that I'm going to want you guys to I'm going to begin to do this thing where I'm going to give some pause for a second to allow you to work on this and then ask questions. So here we have, after having reviewed what we did, that's sort of mainly what we did last time was this, and just what we reviewed with that first problem. So now we have a second experiment, which is the experiment of tossing 2 4-sided dice, 1 green and 1 red. Okay, so first of all, what's the size of the sample space? Well, it helps to take each outcome. It consists of a result for the green die and a result for the red die. So we want to be able to have a notation, a name for each outcome, and because then we could list all the outcomes and see, well, the green die, since it's a 4-sided dice, could be 1, 2, 3, or 4. The red dice can also be a number 1, 2, 3, or 4. And we're going to make the convention that the green die is first. So we always are going to have notation sort of green, then red, so that we're just going to write 4/3. Now, again, this is not 43, so you have to sort of restrain yourself from reading this as 43 and just read it as 4/3, because it's the green dice was a 4, the red dice was a 3, and we don't want to put, some people might want to put a comma in here, but then that's a problem when we list these items in a set, because we use commas to separate the outcomes in a set. So again, this is not the number 43, it's the outcome 4/3. Okay, so what's the size of the sample space? We have to use our counting principles, and since the green dice is independent of what the outcome for the green dice is independent of what happens for the red dice. So, and that's our multiplicative counting rule. So we can then write down this. And so take a moment and fill in this slot here, or write down a piece of paper if you're not following along with the editing your PDF. And I will then pine. Okay, well, let's look at the answer now. Hopefully this is the same thing that you got. Well, there's 4 possibilities here, so we're writing down the number of possibilities. And we're writing down the number of possibilities here for the red die, the green die first, the red die, and 4 times 4. So there's 16 possibilities, and that's the size of the sample space. Oh, there we are. We have a slot for it. Okay, so now what's the notation for the outcome of green 2, red 4? This is the outcome with a green 2 and red 4. Well, take a moment and figure out what you would write down for that. And I think you're going to be pretty clear that what you write down is 2, 4 for the outcome. Okay, now I'm going to then again pause the recording here while you work on what is the definition of the event in which this outcome occurs. So pause the recording yourself if you're listening to this afterwards. Continue. Okay, so the question is, it's important to distinguish between an event and the probability of an event. So what's asked for here is an event which is a subset of sample space. So the sought after answer is the name of the list of outcomes that are in the subset, which is here just one of them, 2, 4. And then now if I was to go, and we'll do the probability later, if you wrote down something like the probability of E24 would be, well, there's only one outcome in this subset, and then there's 16 outcomes in the sample space. So the probability would be 1/16. Okay, so here you get to try it again, in which on D, what is the definition of the event in which the green die produces a 3? Okay, so I think what I'll do is I'll stop the recording